Hello students, welcome to innovative classes. We have just studied in previous video about the graph of y equal to f greatest integer x. That means greatest integer a is applied only in x. Now we are going to study in this video about the graph of y equal to greatest integer fx. But I want to recall the memory about the graph of y equal to greatest integer x. For this, we are going to take an example. This example is that graph of y equal to log greatest integer x. Just this question is only to recall the previous concept. For this, first draw the graph of y equal to log x and then use the concept of log greatest integer x. For this, we take x-axis, this is x-axis, this is y-axis. Graph of log x is like this. This is 1 0 at x equal to 1, log 1 equal to 0, y equal to 0. Here we take a integral point on x-axis. Integral point on x-axis is 1, here 2, here 3 and here 4. From these integral points, we draw vertical line to intersect the graph. Draw vertical line to intersect the graph. We proceed the graph of y equal to log x so that x equal to 4 line intersect the graph. Okay. Now from intersecting point, take a horizontal line from one vertical line to next right vertical line. This is part of graph. But at x equal to 2, log y equal to log 2, because greatest integer 2, when we put the value of x equal to 2, then y equal to log greatest integer 2, integral part of 2 is 2, so y equal to log 2, which lie on the graph of y equal to log x. This point exists, but this point does not exist, so we plot here the open circle and here dot circle. From this intersecting point, we draw horizontal line to intersect just right vertical line. At x equal to 3, y is not equal to log 2, so this point is excluded. At x equal to 3, this point included. Because when we put the value of x between 2 to 3, its integral value must be equal to 2, so y equal to log 2, y equal to, this is point at x equal to 2, y equal to log 2, this is point 2 log 2. When we put the value of x between 2 and 3, greatest integer of number lying between 2 and 3 is equal to 2, so y equal to log 2. From this point, from this intersecting point to just right vertical line, we draw horizontal line. In this interval, y is always becomes equal to log 2. So this is part of graph. When we take the value of x between 3 to 4, the integral point of number lying between 3 to 4 must be equal to 3, so y equal to log 3. X equal to 3, y equal to log 3, and between x equal to x lies between 3 and 4, y must be equal to log 3. This point is x equal to 3, y equal to log 3, 3 log 3, and from this point to this point, at x equal to 4, y is not equal to log 3. So this point excluded, this point included. This point is y equal to x equal to 4, y equal to log 4. So this is the graph of when we take the value of x between 0 to 1, integral part must be equal to 0. So log 0 is not defined. So there is no portion of the graph, final graph, between x equal to 0 to 1. Graph first start from this point at x equal to 1, integral part of 1 is 1. So y equal to log 1, which is equal to 0, 1 0. After that, this is portion of graph, this is also portion of graph, this is also portion of graph. This type of graph is called ladder graph. This type of graph is called ladder graph. So we can write that this graph, this type of graph, this type of graph is called ladder graph. Ladder graph. Because this graph appears like a ladder. So this type of graph is called ladder. In graph of, or in all graph of function like y equal to f greatest integer x, ladder graph comes out. All graph appears as a ladder. So this graph, this type of graph, that means graph of type y equal to f greatest integer x is a ladder graph. Okay. Now we start to draw the graph of y equal to greatest integer fx, and that means second type of graph. Graph of y equal to greatest integer fx. That means greatest integer is applied in the whole function. For this, we take some example. Draw the graph of, question is that draw graph of first y equal to e greatest integer x, y equal to greatest integer sin x, y equal to greatest integer log x, and so on. First, to draw the graph of this kind, that means graph of y equal to greatest integer x. First we draw the graph of y equal to x, then we use the concept of greatest integer x. For this, we draw the graph of y equal to x, which is, this is the graph of y equal to x, this is y axis and this is x axis. At x equal to 0, y equal to 1, this point is 0 1. Here we take the integral point, on y axis, because y right hand side is integer, so y must be integer. To therefore to take a integral point on y axis, this point is y equal to 1, this point is y equal to 2, this point is y equal to 3, and this point is y equal to 4. From these integral points, draw horizontal line to intersect the graph of function. So these are intersecting point. Of graph of y equal to x and horizontal line from integral point on y axis. From these points, intersecting points, draw vertical line. This is already vertical line. If we see the graph, if we see the value of Vx, that means y coordinate, value of Vx between these two vertical lines, value of Vx between these two vertical lines lies between 1 to 2. This is graph of y equal to Vx. On this graph, y coordinate lies between 1, minimum value of y, that means minimum value of Vx is 1 and maximum value of Vx is 2. That means value of Vx lies between 1 to 2. So integral part must be equal to 1. So in this, so the graph of the final function y equal to greatest integer ex between these two vertical lines must be this. But this is not the part of graph. Here we again study the value of Vx between these two vertical lines. If we see the value of Vx, this is graph of Vx, and value of Vx lies between 2 to 3. Its value lies between 2 to 3. Therefore, integral part must be equal to 2 between these two vertical lines. So this is part of graph. This is not part of graph. This is part of graph. Between this intersecting point must lie, because at this intersecting point value of Ex is 2. So integral value of Ex must be equal to 2. So y equal to 2. This point exists. Now between these two vertical lines, we see the value of Vx. Value of Vx lies between 3 to 4. So integral part of number between 3 to 4 must be equal to 3. So y coordinate must be equal to 3. That therefore graph between these two vertical lines must be this horizontal line. But this point must be excluded, because value of Ex at this point, value of Vx is 4. So integral part must be equal to 4. So y coordinate for corresponding to this point, y coordinate must be equal to 4. So this point exists, but this point does not exist. Intersecting point exists, but horizontal line which intersect the vertical line does not exist. So this point does not exist. This point must exist. This is also graph of this category, y equal to greatest integer fx. Okay. Second question is that y equal to greatest integer sin x. Y equal to greatest integer sin x. Y equal to greatest integer sin x. For this, we draw the graph of y equal to sin x. At x equal to pi by 2, we take x equal to pi by 2, x equal to pi, x equal to 3 pi by 2, and x equal to 2 pi, and x equal to 2 pi. This is y axis. At x equal to pi by 2, maximum value of sin x 1, minimum value of sin x minus 1. At x equal to pi by 2, 1. At x equal to 3 pi by 2, value of sin x must be equal to minus 1. So graph is like this. Graph is like this. This is graph of y equal to sin x. Here we take the value of integral value of sin x. That means integral, we indicates the integral point on y axis. Integral point on y axis is minus 1, 0 and 1. So corresponding to this integral point, we draw horizontal line to find out the integral point on y equal to sin x. So integral point on sin x is that means this point is x equal to pi by 2, y equal to 1. So integral point of sin x at this point is 1. Integral point of sin x, value of sin x at this point is 0. Value of sin x at x equal to minus pi by 3. That means we can also draw, we have already known the integral value of sin x. So there is not requirement of, and there is not requirement to indicate the integral value on y-axis. We have already uh, drawn that, we have already taken the integral point on sin x. Integral point of, integral value of sin x is 1 here, integral value of sin x is 0, integral value of sin x is 0, integral value of sin x is minus 1, here integral value of sin x is 0. From these points, that means from integral point on sin x, we draw vertical line. We draw vertical line at x equal to 0. Already vertical line has been drawn. At x equal to pi, we also draw vertical line. Here we also draw vertical line. Here we also draw vertical line. We see the value of sin x between x equal to 0. When x equal to 0, sin is equal to, sin 0 equal to 0, so y must be equal to 0. This point exists. But between these two vertical lines, the value of sin x, from the graph it is clear that value of sin x must lie between 0 to 1. Value of sin x must lie between 0 to 1. Therefore, integral point must be equal to 0. So graph between these two vertical lines must be this. This is graph. But at x equal to pi by 2, this point does not exist because value of sin x is 1. So at x equal to pi by 2, y equal to 1, integral part of 1 is also 1. So this point exists. This point exists. Again, between these two vertical lines, value of sin x lies between 1 to 0. That means value of sin x lies between 0 to 1. Therefore, integral part must be equal to 0. So this is also graph of main function. At x equal to pi, sin pi is equal to 0. So integral part of 0 must be equal to 0. So this point exists. Again, we see the graph of sin x between, we see the value of sin x between these two vertical lines. We see here from the graph of sin x, value of sin x lies between minus 1 to 0. Value of sin x lies between minus 1 to 0. Therefore, integral part of number between minus 1 to 0 must be equal to minus 1. So this is the graph y equal to minus 1. This point does not exist because at x equal to pi, this point exists. At x equal to pi, sin pi is 0, integral value of 0 is 0, so this point exists. This point does not exist because at x equal to pi, sin x is not equal to minus 1, sin x is equal to 0, so this point exists, this point excluded. Again, we see the value of sin x between these two vertical lines. We see the value of sin x lies between minus 1 to 0. So integral part of number between minus 1 to 0 must be equal to minus 1. So this is the graph. This is the graph at x equal to 2 pi. This point excluded. Okay. We have studied the graph of y equal to greatest integer x and y equal to greatest integer sin x. Similarly, we can draw the graph of y equal to greatest integer log x by applying this concept. So conclusion is that this is graph of y equal to greatest integer sin x. Only deep line belongs to the graph, intersecting point must belongs to the graph, intersecting point of vertical line must intersect to the graph. This portion is graph, this portion is graph. Only deep line is graph. This point must exist in graph, but this point excluded. To denote the portion of the graph, we use we will use the different color in next class, from very next class. So conclusion is that to draw the graph of of y equal to greatest integer fx, take a integral point on y axis. From these points draw horizontal line. From these points draw horizontal line to intersect